Okay, so last section, just systems of linear inequalities. So and we're only going to look at 2 by 2. Well, we're going to look at systems with 2 variables. We might have more than 2 inequalities, but we're only going to look at linear inequalities involving 2 variables. Remember what those looked like, right? If we graph a linear inequality in 2 variables, it's boundary and then borderline and then a shaded half plane, right? And so we're looking for solutions of systems of multiple inequalities in 2 variables. So we're going to look for all the places where those solutions overlap, where they intersect. Okay, so just some vocabulary. This is just for your notes. So this will show up. It'll be in Google Classroom today if you want to look back at this stuff. 2 or more equations make up a system of linear equations. 2 or more linear inequalities make up a system of linear inequalities. A solution to a system is always the same thing, whether it's equations or inequalities. A solution is an ordered pair if it satisfies each of the parts of that system. So in this case, if it satisfies all of the inequalities. So for example, well, not quite there, I guess. Graphing, how do we graph solutions of systems of linear inequalities? We just graph all the inequalities and look where they overlap. That's it. It's really that simple. So what if we wanted to graph this system? Well, we're just gonna, let's go through one of these. What if I want to find all these solutions? I've got to graph this system, so here it is. So walk me through that. How am I going to graph this solution of inequalities? Let's graph the first. We'll make this one red. How about? Remind me, how do I graph that inequality? Say it again. Well, okay, but now this time we're talking about, this is a little bit different right now. If you're thinking about this in terms of, like, if you're comparing this to a system of linear equations, think about what a system of linear equations does. We've got 2 lines that intersect in a single point, right? This is going to be different because we're going to talk about entire overlapping regions, right? The half planes are going to intersect in regions that are going to contain an infinite number of points. Okay, so we could put them into slope-intercept form, right? That's a pretty easy way to graph a linear inequality in 2 variables. And this one, all I've got to do is subtract the 3x, right? So we just get the inequality y is less than negative 3x. Okay, so what's that look like? Help me graph the boundary line. What is that boundary line? Where would I start? 0, okay, because the y-intercept is 0, okay. So we got a point right here. And then how am I going to get a second point? Down 3 over 1, good. Okay, so if we go, we rise by negative 3, we run by 1, and we get a second point. Okay, how do I graph this boundary line? It's dash line. Good, right? How come? Oh my goodness. What's this thing doing? It's kind of glitching out. Okay, good, because it doesn't include an equal sign. So there's my dashed boundary line. And then which half plane am I going to shade? Yeah. Okay, look, we know we've got y is less than my boundary line. If y is less than the boundary line mx plus b, then that means I'm shading below, right? Does that make sense? Because y is the vertical variable. So I'm shading down from this line, which puts me into this half plane. So that's the one I'm going to shade. There it is. Okay? Next line. We'll make this one blue. What could I do? Let's get all those Chromebooks closed. I understand the temptation to try to get some stuff done, but it's much more efficient for you guys to just see this now over a short period of time than have to go recreate this later. What do you think? Okay, meaning put it in slope-intercept form? Okay, we could do that. That's fine. We could put this in slope-intercept form, subtract the 2x, divide by 5. That works great. If I do that, oops, 5y is greater than or equal to negative 2x plus 10. Then what? Divide by 5, and I get y is greater than or equal to negative, what, 2/5 x plus 2, right? And that makes it easy to graph. Okay. We have another option, and for you guys, I want to just, that's fine. And doing it that way that's a great way to do it. But class, at this level, I want to talk about maybe another way we could do this too, just to remind you. Anybody see another approach rather than putting this into slope-intercept form? Given that all I need are 2 points to graph a line, do you see 2 other convenient points that I could have gotten from this really easily without doing much at all? Yeah, right. And why is that such an easy thing to do here? Right, and you get the strategy, right? If I want to find the y-intercept, that's going to be where x equals 0, so I can do that cover-up trick we talked about. I could just cover up the 2x and solve for y. If I want to find the x-intercept, I set y equal to 0, so I can just cover up the y term and solve for x. When you look at this thing and you spend just a couple seconds looking at this, how could you tell right away, okay, that's not a bad strategy. That's going to work out pretty well. Yeah, right? 10 is divisible by both 5 and 2. Does that make sense? It's a multiple of both A and B, right? Both the coefficients of x and y, and so it's really easy for us to find those intercepts. They don't end up being inconvenient fractions. They end up being integers, and so that's a pretty easy way to go. So let's do that, just so we can remind ourselves about a really simple way of doing this stuff. When it works, it's great. So what is our y-intercept then? Yeah, 2. Good, that's a plus, isn't it? Yeah, 2. Okay, so we get a y-intercept of 2. So we have the point 0, 2. So right there. And my x-intercept is 5. What kind of line am I using to connect my 2 points? Solid line. And okay, now if I'm doing it this way, how am I going to find which side I shade? If I put it in slope-intercept form, it's obvious, because then the relationship between y and the inequality tells me where to shade. How could I do it with this, or with this up here, right? If I don't do anything to the equation, how could I know which side to shade? What are some strategies? What do you think, Caden? Okay, yeah, be careful with that. But yeah, so you have to just kind of imagine to yourself, if I were to put this into slope-intercept form, what would I get, right? I would get, if I isolated the y, in which direction would the inequality sign point? I'm subtracting this term to the other side, which is irrelevant, and then I'm just dividing by 5, right? So because I'm dividing by a positive, the coefficient of y is positive, the inequality sign doesn't flip. Everybody get that? And so this would give us, if we did this, if we did solve for y, all we need to know is that we would get y is greater than or equal to something on the other side. Right? I could kind of just perform those steps in my head, and just all I have to focus on is just the y and the inequality sign. That's one way to do it. Good. What's another way? And don't be annoyed by the fact that I'm asking you a bunch of different ways of doing this, because this is how you become a really good mathematician, is you look at lots of different ways that converge on the same result. So what's another way I could do it? Do what now? What do you mean? Oh, okay, yeah, test a point, exactly, right? We could test a point that's not on our line, and the most convenient one would just be the origin, right? So we could test this point right here, the point 0, 0, by evaluating the inequality at that point and seeing if it works. Does that ordered pair satisfy the inequality? If I plug in 0 for x and 0 for y, what do I get? What does that blue inequality become? Okay, good. It's going to become 0 on the left side is greater than or equal to 10. True or false? False. Absolutely. So if that's false, then that's not a solution. So which side would I have to shade? The top. I shade away from the point if it's not a solution, because the solution set does not include that. Good. So we'd end up with, whoops. So where's the solution set going to be then of this system of inequalities? Yeah, it's going to be this infinite slice of pizza right there, right? So it's going to look like this is going to be the boundary, right? We're going to have a solid boundary line until we hit that intersection, and then it's going to be dashed, and I'm just going to shade in that area. Okay, make sense? Give me thumbs on that. Does that make sense, everybody, how we did that? Okay. All right, so, yeah, and here's just for your notes. You know, there it is. Okay. Okay, we could end up with something, just so you're aware, we could end up with two inequalities that never overlap, in which case there's no solution, right? There's no intersection of the regions, and so that would be a case where no solution. Why don't you, okay, so let's try one of these in Desmos. I'll show you how to do this. It's so easy in Desmos. So go ahead and open up your Chromebooks. Go to Desmos Graphing. Okay, and then literally the nice thing about Desmos is you don't have to solve for y. Like if I can just leave them exactly the way they're written. So this top one, I would just write as x minus y. And then you don't need to use, you can just use to the right of the m, you see the less than and greater than symbols, just use those. Those are convenient. Is less than 3, and look what it does. It gives me the graph, and it even uses a dashed line. So Desmos is pretty smart. Here, let's do something, let's make this one greater than or equal to, just so you can see the difference. So I come down to the next one, I type x plus 2y. How can I type that greater than or equal to without having to go down and open up the keyboard and waste time? Good, yeah, you just hit the greater than and then type an equal and it merges them. And there you go. Look, and it gives me a solid boundary line. Okay, and then finally we just do y is less than 3, and we got it. And so it's sometimes these get a little bit muddled up with all these colors, but you can easily just go up here and you can turn each color on and off by just clicking on, you know, on that icon, and then you can see, you know, where is the overlap. So clearly it's that middle region right there, right? Everybody see that? Okay. All right. If I wanted to test an ordered pair, like what if we wanted to, I wanted to know, for example, if Is 3-2 a solution? How could I test that graphically using Desmos? Put it, yeah. And you know how to graph an ordered pair. You just write the ordered pair. Where's my... So I could just come down here and type in the ordered pair 3, 2, and look what it does. Okay, so is it a solution? Yeah. Okay, good. All right. And again, for your notes, there's the graph. Okay, so again, like this is one where, you know, I don't need to probably spend too much more time on this, but all I'd have to do in Desmos to graph this is just graph all those inequalities. And I get something like that, and I can see where the intersection is. Okay, how about, I do have my, I'm pretty sure, let me check here. I think I've got my emulator finally installed. I want to show you this stuff on your TI-84s. Okay. Turn that off. There we go. Okay, yeah, this is working, good. So here's the TI-84. Do that. So you can see the screen a little better. Okay, so what you do on this is, if I want to graph inequalities, I want to go into, I got to remember this, it's been a while since I did it. You have to go into apps, and you want to go down and you want to choose the Inequals app. And if you don't have that, you want to install it. And I might be able to help you do that. So you can just type a 7. So again, go to apps, go to Inequals, and then you press any key to continue. And then what's nice about this with Inequals is you have the option here of converting these directly into inequalities very, very simply. So like I think I hit the, no, I hit the left and right arrow, I think. No, what do I do? Darn it. Oh, I know what it is. I go to Math. Is it number? Do you guys, anybody know? Okay, so I'm going to test. Yeah, okay, that's it. Perfect. All right. So I go second, math to get to the test menu. There we go. And so I would, for example, let's graph the bottom one first. So y is greater than or equal to 0. So I would just choose 4 and then type a 0. Oops, what happened? Four. Are you guys figuring, I can't remember how to do this. You guys figuring this out? How come that didn't change that? Have you guys figured out how to change that to an inequality yet? Maybe it was over here. Oh, that might have been it. No. Man, I can't remember how to do that. I thought that was supposed to work. Okay, I'm gonna have to come back and show you. I'm gonna have to reacquaint myself with this. It's been a little while since I did it. So we'll skip that for now. I'll come back and show you when I figure this out. Okay, let's look at one application, and then I'm gonna turn you loose on this. So go ahead and click those closed again. So what about a situation like this? A retired couple has up to $50,000 to invest. Right away, we should be able to recognize that this is a system of inequalities and not equations. How come? Up to. What does up to mean? Yeah, it means less than or equal to, doesn't it? Right? A couple has up to $50,000 to invest, so they might have $45,000 to invest or $40,000 to invest, right? They could have 50, but no more than that. So that's an inequality. Okay, so right away we can see we've got a statement where we're going to need an inequality. Okay, so whenever we're doing an application like this, we're dealing with an application like this, we need to start talking more about these things. What's probably the first thing we want to do? Because our goal here, right, is to convert this from a bunch of cumbersome words into some math statements, some very clear, unambiguous math statements. But in order to do that, what do you think? Yeah, we need variables, right? We need to assign some variables so we know what are going to be the ingredients of our math statements. And usually it's easiest just to stick with X and Y and things like that. So if we read through this, retired couple has up to $50,000 to invest. You're the advisor, so you recommend they place at least $30,000 in treasury bills and at most $10,000 in corporate bonds. So we're supposed to write a system of linear inequalities that represents the possible amounts of each type of investment. So what would our unknowns be here then? Say it again. How much they put into each different type of investment, right? Those are the things that we can vary, and those are the things that essentially they're asking about. What are some investment amounts that would meet these criteria, right? So we're going to let X be then the money that we're investing in T-bills, and we'll just say in thousands, so we don't have to have such huge numbers, right? We'll measure that in thousands. Y is going to be the amount invested in corporate bonds, in thousands. And what would that first, let's make this red. What would this first sentence translate to mathematically then? That sounds pretty complicated. The first one should be that they have a total of $50,000 to invest in either of them, right? So what's that mean? Say what you said again. Maybe I just didn't hear it right. Okay, I'm going to disagree on that first sentence. The first sentence is really, I don't see any 30s in that first sentence. Right? They're total. When we say total, what's total mean here? Say it again. Right. But if we've got two different kinds of investments to make, X is T-bills, Y is corporate bonds, what's the total mean then? If you're investing, what's total imply here? Okay, but how do I turn that into a mathematical operation? Or what does that mean mathematically? What's that mean? The total of those two investments. I don't know if I'm asking very good questions here. When you're investing, you're investing a certain amount of X and a certain amount of Y, presumably, right? But your total can't exceed 50,000. So how can I make that an inequality? less than or equal to. So we know we got that part right. We know we've got a less than or equal to. There you go, x plus y, right? That's all it is. X plus y. Because we're talking about the total of our investment, so that's the amount invested in x, whatever that is, we don't know what that is, plus the amount invested in y. Whatever they are, they have to be less than or equal to 50,000. Okay, does that make sense? Give me thumbs on that, right? Is that okay? Now how about the next one? You recommend they place at least $30,000 in treasury bills. Okay. Okay, so what's that mean? Yeah, at least means 30,000 or more, right? And treasury bills is an X issue. So X has to be greater than or equal to 30. Because remember, we're just measuring in thousands. Okay? How about this one? At most, 10,000 in corporate bonds. What's that going to be? Okay, y is less than or equal to 10. Okay. All right, that seems pretty good. So we can just maybe look at that system that we've seemed to have taken care of all those parts. Okay, so let's graph that and see what we get. Okay, oops, where'd that go? We're still missing something here, and I'm going to see if anybody, I'm not going to say anything about it for a little bit, see if anybody can get what it is. When we graph it, I bet maybe it'll show up. So first was x plus y is less than or equal to 50. Probably have to zoom out a little bit. Okay. Then we had x is greater than or equal to 30. And then we had y is less than or equal to 10. Oops, what am I doing? Gotta go down. Okay, so our solution then appears to just be that little, kind of that section down in here. What's wrong with that? Anybody see something wrong with it? Say it again? Yeah, it goes into negatives, right? Look, our solution includes negative results. So this implies that we could get a solution like, for example, like what's an ordered pair that's in this region? Something like 40, negative 20. Well, look, that's in our solution set, but that's a tough investment to make, right? If you're going to invest $40,000 in T-bills and negative 20 in corporate bonds, how do you invest negative 20? I don't know. I don't think you can, right? What's that? They pay you? Yeah, I don't know. That might be a good deal. So what are the implied other inequalities here? Even though they're not stated explicitly, you always have to look for the implied statements too. What are the implied inequalities that we just assumed without even stating? Yeah, you can't invest a negative amount, right? So we really would also want to include x is greater than or equal to 0, and y is greater than or equal to 0. And I probably need new colors on those, don't I? Let's go orange and purple. There we go. And so now it gets pretty muddled up, but you can see that now that's the region that contains all our solutions. That little trapezoid down there at the bottom. Okay, everybody see that? Okay. All right, I'm going to shut up and let you work. Put that assignment up, and when I figure out, maybe I won't even do it today. When I figure out the TI-84 stuff, I'll just show you like on Monday or something. I won't interrupt you today, I'll let you work.